In this video, we're going to learn how to find reference angles and coterminal angles. So the first thing we're going to start with is looking at reference angles. So just a reminder, when we talk about angles, positive angles always rotate counterclockwise. So if you see a positive degree, that means we're rotating counterclockwise. So if you think back to geometry with our rotations, and negative angles always rotate clockwise. So for example, if we have a positive angle, let's say 200 degrees, that's going to end up being down here somewhere. So starting at 0, going past 90, going past 180, it'll end up over here. Again, measuring counterclockwise. And a negative angle, if we start at 0, so starting here, and let's just say we do negative 50. So this would be an example of negative 50 degrees, measuring clockwise. So keep in mind when you're doing these, always draw the arrow, the direction that you're going, just to make it clear as well. So if you're going positive, it's counterclockwise, negative, it's clockwise. So I'm just going to make a note here to draw arrow to indicate direction. So then what we're going to look at is what we call the reference angles, which are always going to be these little acute angles that are touching the x-axis. So we've done a little bit with this. We've done the bow tie. We've talked about that a little bit. So that's really what we're going to focus on today, or what are the reference angles. So when I look at this 200-degree angle, the reference angle is this little acute angle here that's touching the x-axis. This negative 50, actually the reference angle of that is going to be the 50-degree angle. And that's going to be useful for finding exact trig values, which is what we're going to look at tomorrow. So for right now, reference angles, they're always going to be acute. So I'm just going to write that, always acute. So what that means is their value will always be between 0 and pi over 2 radians. So value between 0 and pi over 2 radians, or you could say between 0 and 90 degrees. Acute angles are always less than 90 degrees. It's the angle that's found in the bow tie. So let's go ahead and we're going to just kind of demonstrate on these two set of axes here. The first one I want to do is just draw that bow tie picture. So here's our bow tie. And we call it a bow tie because it actually looks like a bow tie. So all of the angles here that are touching, so I'm just going to label this as theta, all of these angles that are touching the x-axis are the reference angles. So they're always going to be the acute angles, always measuring less than 90 degrees, and they're always touching the x-axis. You'll never use angles that touch the y, so just be aware of that. So this angle right here is the reference angle in the first quadrant. Then we have this reference angle in the second quadrant, which would actually be used if we were finding this larger angle. And then the third quadrant is going to use this reference angle right here. So if we were trying to find this big angle, and then this last angle, so I'm not going to draw it in, but if we were to go to there, we would be using this reference angle in the fourth quadrant. We're going to do more with that in a minute, so I don't want to crowd that picture up too much. The other thing I want to do on this set of axes is to talk about more specifically, how do you actually find the measure? So if I was looking at this angle right here, so from here to here, how would I actually find that? So let's just write a little note here. So to find reference angle, you're going to use these following measurements. So if it's in the first quadrant, the reference angle is just going to equal whatever theta is. So if I say 10 degrees, that is the reference angle because it's in the first quadrant. So the reference angle in this situation is just equal to whatever your given angle is. So theta is going to be your given angle. If I'm in the second quadrant and I want to find the reference angle, well, then I'm going to take 180 degrees and I'm going to subtract off theta. Or I'm going to take pi radians and subtract off theta. So I'm going to take 180, this entire measurement from 0 to 180, and I'm going to subtract off the theta. And so let's say I subtract off 100, that means the reference angle would be 80. If I'm in the third quadrant, we're going to do the opposite of that. We're going to do theta minus 180 because this time I want this section right here. So I'm going to get rid of the 180 or pi radians. And then if I'm in the fourth quadrant and you want to find the reference angle, it's going to be 360 minus theta, or it's going to be 2 pi radians minus theta. And that's how you're going to find the reference angle. So all of these equal the reference angles. So if we look at these examples with some numbers to help this make sense, the first one's the 200, which is actually what we sketched up top there. So if I take and draw my 4 quadrants, so think about 200. So this is 0 degrees, 90 degrees, 180, 270, and then back to 360. The 200, if we start at 0, the 200 would end up somewhere over in here. So this is my 200 degree angle. What I want to know is what's the reference angle. So I'm going to go ahead and draw in this triangle the part of the bow tie that we see. And my goal is to figure out this angle. So basically what you're going to do is you're going to do theta. So think about what we have right here, theta minus 180. So really, if you don't have that memorized, just do what makes sense. So if I'm trying to figure out this portion and this whole thing's 280, I want to get rid of the 180 so I can figure out the reference angle. So I'm going to do 200 minus 180. I'm left with 20. So this angle is the reference angle, which is equal to 20 degrees. And that's it. So let's try some other ones. We're going to see some different scenarios. So this next one is now we have our measurement given to us in radians. We have fractions involved, which isn't as clear-cut to see. So what we can do is we can draw our axes, but instead of putting degrees around these, I'm going to think about them in terms of radians. So this is 0, this is pi over 2, this is going to be pi, this is 3 pi over 2, and this is 2 pi. But what I really want to think about these as instead of each quadrant here being a half pi, I want to change it so that my denominators are all 4. So I really want to think about this in fourths. So what you can do is, well, if I think about converting this over to a denominator of 4, it means I'd have to multiply the top and the bottom by 2. So times 2 to make this 4. So then this would be 2 pi over 4. This is going to end up being, if I want to make this over 4, that would have to be 4 on top, timesing the bottom, both the numerator and denominator by 4. This would have to be times 2 to get to 4. So times 2 makes this 4, times 2 makes this 6. This is going to be, this is like over 1, so times 4 gives me 4, times 4 on top gives me 8 pi over 4. So now if you think about this, now that they have common denominators, you can think about this easier as, well, where does it lie? It lies between 6 pi over 4 and 8 pi over 4. So that means it's going to lie over here, which tells me that my angle starts at 0 and it's going to end up right here. So this is 7 pi over 4. You can also think about it too if you don't want to relabel all your denominators. Just think about breaking this up into fourths. Or think about it as, okay, well, 2 pi is equivalent to 8 pi over 4. This is just shy. It's pi over 4 shy of being 2 full pi's. So you can think of it that way too, just kind of what makes sense. So we'll see some other examples, but that tells me here's my reference angle. So the 8 pi over 4 is equivalent to saying 2 pi minus theta. So I'm going to do 8 pi over 4, subtract off the 7 pi. So we have this whole thing minus the 7 pi over 4. That leaves me with pi over 4. So this is going to be pi over 4. And I'm just going to write my reference angle is pi over 4. And remember, it's always the angle that's touching the x-axis. The next one here, now we have a negative, so that means we're going the opposite direction. So if we draw in, that means I'm starting at 0. This is really going to be negative 90, right? If I'm going clockwise, this is going to be negative 180, negative 270, negative 360. So if I start here, I'm going to negative 150, means it's going to end up right in here. And again, I'm just going to draw that arrow to represent that's negative 150. So I want to know what's this reference angle. So in this situation, if you're following these rules up here, this would be saying negative 150 minus 180. Oops. I lost which page we're on. There we go. So if I look at those rules, so I could say negative 150 minus 180. Minus negative 180, sorry, because this is a negative. Or you could just think about it as, okay, we have to do 180. This whole thing's 180. Subtract off the 150, which is exactly what this is saying. So 180 minus 150. So we get 30. So that reference angle is going to be 30 degrees. So again, I don't always think about those rules from up top. I kind of just look at the picture and think, okay, what makes sense here? If I'm trying to, if this whole thing's 180 and you want to know this angle, well, just do 150 from 180 to get that. If we look at the next one, so now it's 2 pi over 3. So now we want to think about this in thirds. So think about what you need. I always think about the whole numbers first. So think about pi. What would this have to be to equal pi? It would have to be 3 pi over 3. So what that means is think about dividing from 0 to pi. Think about dividing this into thirds, and this is 2/3. So that means it's going to be over here. So this will be over here. And again, 3 pi over 3 would be right here. So I know that I'm just short of, so let me just actually switch this to 3 pi over 3. So the reference angle is going to be 3 pi over 3. So this whole thing minus the 2 pi over 3. So that gives me pi over 3. So that means that this is going to be pi over 3. So the reference angle is pi over 3. I think I just said the wrong thing. Pi over 3 is what your reference angle is. If we look at the next one, 320, so back to degrees. I always think that the degrees are easier to visualize. So 320 degrees is going to end up being past 270, just shy of 360. So it's going to end up being over here. So this is 320 degrees. So to figure out my reference angle, to figure out this angle right here, take the whole 360 and subtract off what you don't want. So 360 minus the 320. It's going to leave me with a reference angle of 40 degrees. Again, always touching the x-axis, that reference angle. Next one, now we have negative. So we're going to, again, go the opposite direction. We're going to go clockwise. So since this is in radians, I'm going to go back to radians. So this is going to be negative pi over 2, negative pi, negative 3 pi over 2, and then this would be negative 2 pi. Since we're going opposite direction. So this one is going to start here and it's going to end up here on negative 3 pi over 2, which tells us that this is one of our quadrantal angles, which means there's no reference angle. So if you ever have one that lies on one of the axes, that means that there's no reference angle because your reference angle has to touch, it has to be an acute angle, so between 0 and 90 degrees, and touching the x-axis, which in this case is impossible to do. So let's go ahead to the next page. And we're going to do some more practice with this. Feel free to pause the video and just try these and then just fast forward to the answers. Unless you feel like you need more practice, well then just listen to the video. Otherwise, go ahead and try them on your own. So for this one, the only difference of what we're going to do is we're going to also name the quadrant that the terminal side is found. And then we're going to draw our angle, state the reference angle, same thing. So 215, we're going to have it between 180 and 270. So it's going to end up over here. So that's going to be in quadrant 1, 2, and 3. So quadrant 3 is where it terminates. That's what it means when it says the terminal side. This is the terminal side where it ends. So then I want to take 215 and subtract off the 180 degrees that I don't want to find that reference angle. So this gives me 35. So the reference angle is 35 for this one. Next one here, negative 40 means now you're going the opposite direction. So again, always starting from 0, going down, negative 40. So this, my reference angle, is just going to be 40 degrees. So notice that the reference angles are always positive because they have to be between 0 and 90. The negative is just telling you the direction. So in this situation, the reference angle is positive, and that's going to be in the 4th quadrant. For this next one here, you can convert everything to have a denominator of 6. That's one way. Another way is just to think about, well, look at 13 over 6. So this is going to be greater than 2. So if it was 12 pi over 6, so this would be 12 pi over 6. This would actually end up equaling 2 pi. So this is actually going to be just past that. So this is really going to go around once to 12 pi over 6, and then go up to 13 pi over 6. So this angle is actually bigger than 360 degrees. And again, you could label everything, but I'm just looking at this from, I know that this is less than, this measurement is 90 degrees or pi over 2 radians, so half a pi. And I know from 12 pi over 6 to 13 pi over 6, I know that that's less than half of a pi. So that's how I know it ends there. So then to figure out our reference angle, well, to get from 12 pi over 6 to 13 pi over 6, it's just subtract them, and I end up with pi over 6. So my reference angle for this one is just pi over 6. And this one's ending in the 1st quadrant. Lots of technical difficulties. Sorry about all this. So pi, quadrant 1 is what I'm trying to write up there. And then if I look at this one, negative 2/3 pi, again, think about this as 3 pi. So if I look at my quadrants, now we're going the opposite way. This would be negative 3 pi over 3 if we're starting at 0. So negative 2 pi over 3, think about 2/3 of this. So this is going to be negative 2 pi over 3. So my reference angle right here would have to be pi over 3. 900 degrees. So think about this is way bigger than 360. It's actually way bigger than 720, which would be if I went around the circle twice. So let's figure out how much is left. So if we subtract off 360 twice, so I'm just going to say 720 because that means 2 times around the circle. That's going to leave us with 180. So what this really looks like is we're going 1 time for 360, 2 times for 720, and then it's ending up over here, 180 degrees. So this angle is really right here, and it's not going to have a reference angle because it's one of those quadrantal angles. Because it's on the axis. So let's go ahead now and look at a couple other situations, which is what we call coterminal angles. And what we found here is an example of a coterminal angle. It's when an angle terminates on the same side as another angle. So for example, 180 degrees is coterminal with 900 degrees because they end up at the exact same spot. no different than, if I say 900 degrees or I say 180, no matter what, they're in the same position. So two or more angles in standard position that share the same terminal side, so where it terminates, are called coterminal angles. So basically what we do is we just look at it as adding 360 as many times as you want or subtracting 360, because anytime you add or subtract 360, you're basically adding or subtracting a full circle, so it's going to end up in the same position. So if I look at this 200 just as a visual, the 200 ends up over here, which means that the reference angle is 20 degrees. So if I look at which one of these matches, well, if I go this direction, so if I went negative 160 degrees, so 160 plus 20 would give me 180. So if this was negative 160 degrees, those angles terminate in the same spot, so those are called coterminal angles. So that's kind of a visual approach. But there are an infinite amount of coterminal possibilities, because I could just keep adding 360 and keep going around and around, and every time I end up here, it's considered a coterminal angle. You could subtract 360 and go the opposite direction, same thing. So for these examples down here, if we're trying to find a positive measure of a coterminal, that just means we're going to add 360 until we get a positive number. And negative means we're going to subtract 360 until we get a negative angle measure. And any in-between numbers that we come across by adding or subtracting 360 are still considered coterminal angles. So for this first one, add 360 to this, so go around the circle a whole another time, you get 490 degrees. There's your positive. If I want to find the negative, well, I'm going to do 130 minus 360. So basically find the difference, so 360 minus 130, figure out that, and then it'll just be negative because it's a negative 360. So negative 230. So there's my negative. If I'm looking at part B, well, now we're thinking about this in terms of fractions and radians. So think about adding or subtracting 2 pi. So for this one, instead of saying, so I'm going to add and subtract 2 pi, but instead of saying 2 pi, let's make it so it has a common denominator. So this is going to be, we need to make it a 5 on the bottom, so we had to times it by 5 because it was a 1 already, so this is going to be 10 pi. So then this is going to end up being 2 pi over 5. So there's my positive angle. And then I'm going to subtract. So negative 8 pi over 5 minus 10 pi over 5. So this will be negative 18 pi over 5. So there's my negative coterminal angle. And then 740, again, back to degrees. So I'm going to add 360. So if I add 360, I get 1100. So there's a positive coterminal. What's going to happen for this one, though, since it's greater than 360, I'm going to have to subtract 360 several times in order to get the negative coterminal, which just means I'm actually finding more possible positive coterminals. So here's another possible positive coterminal angle. Subtract 360 again. Here's another possible positive coterminal angle. So now to find the negative, now when I subtract 360, now I'm going to get negative 340. So here's my negative coterminal angle. These are all going to be possible answers. You don't really need all of them. You just need to have one because the directions only said one. So these are all positive coterminal angles. So I just gave multiple ones for that one in order to be able to find the negative. And then the last one here, same thing with using 2 pi. So think about it as you're going to add 2 pi to this, which means I really need to make this 4 on the bottom. So I'm going to times it by 4. So times by 4, so 8 pi over 4. So that's going to give us 19 pi over 4. So there's your positive. And then we're going to get the negative by subtracting. So this is going to be 3 pi over 4, which is still positive. So that just means I have to subtract again to get a negative. So there's my negative 5 pi over 4. So again, you could say that this is another answer. So these are both positive coterminal angles. So those are all acceptable. So go ahead and do the homework. And then if you have questions, save them for class tomorrow so that we can go over them.